Okay, so this is the presentation for the planet and gravity and space movement that I did in Unreal Engine 5. This is Nicolas Abondano. So my original plan was to implement three systems. The first main two was a planet gravity system. So the planets will attract the player to the center of the planet, and they will change the rotation of the player. So the down vector now points to the center of the planet. That's how this system will work. And then a space movement system, just a simple system that allow the player to move uh, horizontally, like to the right or to the front in any possible direction, even on air using like a jetpack. And then also when they can also use thrusters to go up and down faster, like a jetpack. So this will be like the space movement components. And then the last system that I planned to do is if these two systems work properly, I could add an orbit system so the planets will move, maybe do orbits around each other or move in do different orbits. So it will be better experience, and because they're attracted to the planet itself, if this system work properly, this one will be easy to implement. But I had much trouble with the gravity system, so I didn't have too much time for the orbit system. That's why I didn't include this in the document. And I also was inspired a lot by the mechanics and system of this game uh, otherwise. So my research was mainly the documentation that I know about Unreal, learning things such as floating point movement, um, like forces, rotation, things that I just know from Unreal. I'm still learning it, but I know a lot of things about programming and Unity. So, and then the tutorial, I use these videos of code like me to guide me first to get an idea of how to implement the system before I did the document. And after I did the document, I had to go to the second video because there was an error that I was getting. So I had to find, I was planning to just use the first video, but the second video helped me a lot with a problem that I had, and was that the rotation of the player was not set properly. I was using the forward vector and the down vector pointing this, and using these two vectors, I was generating a rotator, but this didn't work properly. This was like making the like depending on where the player was, this forward vector was because it's perpendicular. Like it's not how the forward vector should work. How the forward vector should work should be something like this, something that points where you want to go, but instead inside of the planet, not the forward that is here. Um, this is like different. You will go like out of the planet. You want to be inside. So to implement this, the tutorial, how they did it is they do a line trace from the player to the center, and then they have a point in front of the player, and they do another line trace from this to the center, and then the hit points that it gets to a planet, this will be a new direction, the new forward, and that's the new forward that you use for rotation. That was one of the big things that helped me to get through. So the features that the game will have finally is going to be a third person perspective in a 3D environment. It will have a traction planetary system, also a rotation system, a rotation mechanic, so the player gets rotated towards the planet. Interplanetary system, so they can jump and mount inside the planets, and thruster for movement, so they can use the jetpack to move up and down faster. And then also when they are in the air, the speed is different because they're using like a jetpack instead of in the ground that they are just moving like walking. And also I wanted to include multiple planets so they can go from one to another planet. So uh, this is the game. I can do a short demonstration. So right now I have no planet. I'm in the middle of space. I can move forward, backwards with WSD. Can move to the right and to the left. And then if I apply shift, these are forces, so these are move very better. The movement, I couldn't do the movement with forces. I was getting errors, so in the end I just did inputs for the floating pot movement. But the up movement and the down movement are forces, so they feel like you can see that. Right now I just entered the atmosphere of this planet, so I now get attracted to it. This planet has a very low gravity force. I can jump with the space. So right now I'm jumping, and then I jump, and then I use shift to propulse myself up, and control to propulse myself down. And then I can also, let's go to this other planet. I go up with the shift. Now you can see no gravity in the corner in the left. and now another gravity because I now enter the force gravity of this one. This one has a bigger force. You can feel that you go much more faster to the center of the planet. So how this works is I have two blueprints. The first one is just a planet blueprint. This is just a mesh and a collider. And the moment that the player enters the collider, it checks that it has the component body. That is a attack that the attack that the player has. And once it checks that all the player has body, it starts doing a gravitational force. If it leaves, on the other hand, it ends overleap. Now it stops gravitational force. And this is the only thing that does is assign a variable called planet to the player. So the player using that variable, it will get applied gravity. First, I'm going through the main systems, the basic system, which are just movement and rotation. This is mostly about the tutorial, but it was very straightforward. So this was just moving using the X value to move to the right of the camera, and then using the Y value to go to use um, to move to the forward of the camera. Yeah, this is for the left and right. So I use the camera as reference. I don't use the player vector. So that way, depending on where I'm looking at, if I'm looking here, I move forward here. If I move here, I move forward here. So it depends on the camera and not the actual rotation of the whole object. Um, and then also how it works, the rotation is the moment that I change the the look. If I move in the X or Y X using the mouse, in this case, the spring arm, because this is a third person camera, will change its pitch and yaw. For the pitch, yeah, I had to multiply this by -1 because this is a spring. So if I move, like if I use the spring and I move down, like in this direction, I'm actually moving up. Like that's how it works. So I had to multiply that by -1. So yeah, this is the rotation. Now I also have a variable called on air that manages if the player is touching the ground. So whenever it jumps or it goes up, it changes on air to true. And the moment that this ground check, here the player has a ground check that is just a simple uh, collider. Once the ground check overlaps something that is called has the tag ground, on air is false. I also have this function for set on air, and how this works is that the moment that I set something on air, I change the speed to jetpack or to movement. Uh, so that's how the basic movement works. I also have this jump action. So if it's not on air, now it is. So it's set on air check, and then you add force using the up vector. Now the most complicated one, the apply gravity. I did this also with the tutorial. So the apply gravity, how this one works is you get the planet. If the planet is valid, you get the forward. How you get the forward is the method that I explained in the presentation. You do a line trace using the actor location, the planet location, and the player's location, and you also use the forward location. The forward location is just this point that is forward the player. So once you have those 2 points, you do a line trace to the center of the planet, and you get the heat, and then you get a location. And then the location you do from the player to the one that is forward, you get that direction, and this is the new forward vector. This is for the rotation. And then the gravity vector, this is pretty simple. You just get the planet, and then you get the player. So it goes from the planet to the player. This is the normal vector, this is the up vector for the rotation. But if you want to get the gravity, you have to get the opposite. So you get that vector multiply by the gravity strength, and then multiply by -1 because it goes in the opposite direction. You need this for gravity. So um, so you have the gravity vector here. That's the force that you apply to, and then the normal vector, the up vector, this and the forward vector, these two get together and you get the new rotation. Instead of changing the rotation right now, I did something different. I am saving this rotation in this variable, and then you do a force to the player. After that, there is a vertical thrust. So how I implemented it is I get, if the player is pressing shift, I get an up thrust. The player is pressing control, I get a down thrust. I multiply this by 1, this one by -1. And then if I multiply this by the up vector and the vertical force, I get a force to apply it up or to apply down. Also, if the player is not on air, so it's on the ground, and then it's applying a vertical thrust, so up thrust is true, then it's now on air because you are going up and you were not on the, you were on the ground and now you're going up, so you are no longer on the air. That's how this works. I implemented also this thing that is called the actor rotation. So I get just the current actor rotation and the target rotation, and I am constantly on the tick going smoothly to this target location. Thanks to this, the moment that I enter a planet, instead of going immediately to the rotation, you can see that the rotation changes uh, uh, not that fast. So that's how I implemented it. So what I did from the tutorial was most of the logic of the apply gravity and then the movement and the rotation, these two. But these two were uh, like actually pretty straightforward. I could done this on my own. I just used the tutorial because it seems more appropriate. But the main thing that I get from them was the gravity movement. The ground check, the inputs, and the atmosphere. I did it on my how I think it was best. Also a reference to the planet. Because they use like a vector instead of a planet. I prefer to save the planet so I can get the actual gravity of that planet. Because also how they implement in the tutorial is that it's the same gravity for all planets, and I didn't wanted that. Uh, so yeah, that's how the overall system works. Um, I want to in the future continue this system. Add things such as the orbit movement. I still want to add that. There are some moments that if I push the system too far, uh, it can get you can get pretty weird rotations. I also have to tweak the movement input. Right now this is a little bit slow, but sometimes if I put it too fast, uh, now when I'm on the planet, yeah, sometimes like if I push this too far, sometimes the rotation right now is okay, but there are moments that the rotation just starts to not working properly. So I have to do more research, and that will be my presentation.